In this video, we will discuss how to integrate the trigonometric function with different powers. Let's first start about the integration of the trigonometric function without power, means power equal to 1. We have 6 trigonometric functions: sine, cosine, tan, sec, cosec, and cotan, and also 6 hyperbolic functions. So if we start with the trigonometric function, the integration of the function sine x and the integration of the function cosine x, it is directly from the antiderivatives. The integration of sine is negative cosine, and the integration of cosine is sine. The integration of tan x we can write tan as sine x over cosine x, and of course sine x is the derivative of cosine but need negative and the negative outside, so we can write the integration of tan at is negative ln cosine x, and if we make the negative inside the ln, it will be in the power, so we have cosine power negative 1 whole sec. So there is another form for the integration of tan, it's ln sec x plus c. And in the same way, the integration of cotan, as if cotan is written as cosine over sine, so the integration of cotan is ln sine x the integration of sec, x is ln sec x plus tan x, and the integration of cosec x is ln cosec x minus cotan x. Now you can easily integrate the 6 trigonometric functions: sine and cosine, tan, cotan, sec, and cosec. With the same way, the integration of the hyperbolic functions, the integration of sine and the integration of cosine. Also, the integration of sine is cosine, and the integration of cosine is sine x plus c. The integration of tangent also can be written as sine over cosine. So the integration of tangent is ln cosine, and the integration of cotangent, in the same way, cotangent is cosine over sine. So the integration of cotangent is ln sine. Again, the integration of sec and the integration of cosec. Sec x, its definition is 2 over e power x plus e power negative x. Sec is the reciprocal of cosine, so it's 2 over e power x plus e power negative x. And if we multiply by e power x, so we have sec equal to 2 e power x over e power x square plus 1. So the integration of sec is 2 outside, tan inverse e power x, plus c. In the same way, the integration of cosec, its definition is 2 over e power x minus e power negative x, and multiplying again by e power x, it's 2 e power x over e power x square minus 1. So the integration of cosec is 2 outside, multiplying negative, tangent inverse e power x plus c. Now we can integrate the 6 trigonometric functions: sine, cosine, tan, cotan, sec, cosec, and the 6 hyperbolic functions: sine, cosine, tang, and cotang, sec, cosec. Now, what if these functions having a power 2? That means we need to integrate the 12 functions, the 6 trigonometric and the 6 hyperbolic function, if the power is increased to 2. So if we need to integrate cosine power 2, of course we can use the identity that cosine squared x is half 1 plus cosine 2x, and half is a constant outside, and the integration of 1 is x, and the integration of cosine 2x is sine 2x over 2. And if we need to integrate the function sine squared, in the same way, the integration of sine squared, we can first use the identity that sine squared is equal to half 1 minus cosine 2x. So half is constant outside, and the integration 1 is x, and the cosine 2x is sine 2x over 2 plus c. What about the integration of sec squared and the integration of cosec squared? The integration of sec squared is a direct antiderivative, which is tan, because the derivative of tan is sec squared. So the integration of sec squared x is tan x, and the integration of cosec squared is negative cotan. And now, if we need to integrate tan squared and cotan squared, of course tan squared has an identity which can change tan squared to sec squared. Tan squared is equal to sec squared minus 1, and using the integration of sec squared, which is tan, so it will be tan x, and the integration of 1 is x. In the same way, the integration of cotan squared, using the identity that cotan squared can be written as cosec squared minus 1. So the integration of cosec squared is negative cotan, and the integration of 1 is x plus c. Now we can integrate the 6 trigonometric function if its power is 2: cosine squared, sine squared, sec squared, cosec squared, and tan squared, cotan squared. And now what about the hyperbolic functions also with power 2? The integration of cosine power 2. In the same way, cosine power 2, using the identity to reduce the power, half cosine 2x plus 1, and the half is outside the integration, and the integration of cosine 2x, it will be sine 2x divided by 2, and the 1 is x plus c. For the integration of sine squared, we have sine squared with the identity half cosine 2x minus 1. So half is outside the integration, and the cosine 2x is half sine 2x minus x plus c. Of course, the integration of sec power 2 is a direct antiderivative, because the integration of sec, it will be tanh, and the cosec power 2, direct antiderivative, it will be negative cotanh x. For the integration of tanh power 2, tanh power 2 has an identity which convert tanh squared to sec squared. Tanh squared x is 1 minus sec squared. So the integration of 1 will be x, and sec squared is tanh. Finally, for the integration of cotanh power 2, the cotanh power 2 has an identity which is 1 plus cosec power 2. So integration will be x plus the integration of 1 is x, and sec power 2, it will be negative cotanh x. So now, until now, we can integrate the 12 functions, the 6 trigonometric function, the 6 hyperbolic function, and also these functions if its power is 2. And now, what if the power of this function is more than 2 for the trigonometric and the hyperbolic function? And we will have some cases. First, let's start if we need to integrate cosine or sine or cosine or sine with an odd power. So let's see if we need, for example, to integrate cosine to the power 3 dx. If the power is odd, we can write cosine power 3 as cosine squared times cosine. So our integration will equal to cosine squared times cosine x dx. The idea here is that cosine x is the derivative of the sine, and the cosine squared, because its power now is even, as we take cosine from the odd power, cosine squared can be changed to sine squared, because cosine squared is 1 minus sine squared. So after expanding cosine inside the bracket, we have the integration of cosine times 1, which is cosine, minus sine squared times cosine x. The first term in the integration, which is the integration of cosine, which is sine x. And the second term of the integration, we have the integration of sine x to the power 2 times the cosine. And the cosine here can be the derivative of inside the bracket, which is sine x. So our integration can be directly using the power rule by adding on the power 1. So it will be cosine power 3 over 3 plus constant. You can now think that if the power of the trigonometric function cosine is odd, we can take cosine to be the derivative, and the rest of power will be even. We can change this even power to the function sine. So we have sine power 2 and its derivative cosine, so we directly using the power rule. And please remember that the identity between cosine and sine, that cosine squared plus sine squared is equal to 1. And this identity can be written as cosine squared equal 1 minus sine squared, or sine squared equal 1 minus cosine squared. So if we need to change from sine to cosine or cosine to sine without a root is appear, so the power must be 2, 4 or so on, so the power must be odd. That's why if the power is odd, sorry, the power must be even. That's why if the power is odd, we can take cosine to be the derivative and changing the even power to the other function. Let's see another example. If we need to integrate cosine power 5x times sine power 4x. So we now need to integrate cosine or sine function, and one of the functions has an odd power. So again, we can write cosine power 5 as cosine power 4 times cosine. So our integration will equal to integration of cosine power 4x sine power 4x times cosine x dx. Now this cosine x will be the derivative, so we need all the term to be sine. We need to change cosine power 4 to sine, and we can write cosine power 4 as it's cosine squared, and changing cosine squared using the identity, it will be 1 minus sine squared all power 2 times sine power 4 times cosine x dx. After expanding the bracket, the first term will be 1, and we have sine power 4 outside, so it's sine power 4. The second term will be negative 2 sine squared, and we have sine power 4, so it's sine power 6. The third term will be sine power 4, and we have sine power 4, so it's sine power 8, and still we have outside cosine x dx. Now, directly using the power rule, because sine power 4 and the derivative of sine is cosine, so integration will be sine power 5 over 5. And we have sine power 6 and the derivative is cosine, so it will be sine power 7 over 7. And the last term will be sine power 9 over 9 plus c. Let's see another example to make the idea clear. If we need to integrate sine power 3x times root cosine x. Again, we have one of the four functions we mentioned, sine, cosine, sine, cosine, with power odd, which is sine here, power 3. So we can write sine power 3 as sine squared times sine, and we can have this sine to be the derivative. So we have sine squared root cosine x, which is this term, times sine x dx. We have this sine x to be the derivative, and the rest of sine, which is sine squared, which is power even, can be replaced to cosine, because we have cosine squared minus sine squared equal to 1. So we can replace sine squared as it's cosine squared minus 1. And now expanding the bracket, because root cosine, it's cosine x to the power half. So expanding the bracket, the first term, it will be cosine x power 5 over 2, minus the second term will be cosine x to the power half. And again, we have this term, which is sine x dx. Now we can apply the power rule, because it's a bracket cosine power 5 over 2, and the derivative of cosine, it be sine outside. So by adding on the power 1, it will be 7 over 2, and multiplying by 2 over 7. And in the second term, we add to the power 1, it will be 3 over 2, and we have here 2 over 3 plus c. Now, I think the idea is clear that if we have one of the functions, sine, cosine, sine, cosine, with power even, we rewrite this one as sine, and the rest will be an even power because the power is odd, and we take one sign, so the rest an even power, and we can change this even power to the other function, sine to cosine, using the identity. And of course here we have the derivative of cosine, so we can use directly the power rule. And now the question, what if both powers are even, or we have an even power for the function? Let's see, for example, if we have the product of cosine squared x times sine squared x. Now both powers are even, no odd power, and in this case we use the double angle rule that cosine squared is equal to half 1 plus cosine 2x, and we have also sine squared equal to half 1 minus cosine 2x. So we use this rule until the power is finished. So the power must be 1. So we replace cosine squared by half 1 plus cosine 2x, and replace sine squared by half 1 minus cosine 2x. Expanding half times a half, it will be 1 over 4 outside the integration, and 1 plus cosine 2x times 1 minus sine 2x, it will be 1 minus cosine squared 2x. And of course we have 1 minus cosine squared, it's a sine squared 2x. Again we still have sine squared 2x, so we use this identity again. 1 minus sine squared, it will be half 1 minus cosine double angle, which will be 4x dx. Now we have no power, the power is 1. Half is outside the integration, it will be 1 over 8. And the integrating 1 is x, and the cosine 4x, it will be sine 4x times 1 over 4. To sum up this case now, if we have the integration cosine power m times sine power n, we have two cases. The first case, if one of the powers of the cosine or sine, the same also for cosine times sine, if one of the powers is odd, we take from the odd power 1 to p the derivative and change the rest, which will be even, to the other function. But case number 2, if both powers are even, we use the double angle rule that cosine squared and sine squared, it's equal half 1 plus cosine 2x, and sine squared half 1 minus cosine 2x, and simplify until the power is 1. In the next video, we will see what we have tan product between tan and sec with highest power. Thank you.